This video is the continuation of basics of dimensional tolerance. So, I am your Spark. Let's go and watch. Next we are going to see system of tolerance specification. So it explains how to specify the dimensional tolerance value. This is the representation of the tolerance specification system. This zero line is the basic line. Normally, tolerance value is specified in three methods, that is unilateral, bilateral and limit method. We will see this one by one. So unilateral tolerance. It is divided into two types. If the tolerance value is below this baseline, then it is negative tolerance value. And if tolerance value is above this baseline, and then it is positive tolerance value. For example, we will take this circular shaft with some dimensions. This dimension is for our reference. Here, basic size is 50 mm diameter and positive tolerance value is from 0.0 to 0.5 mm. And in this figure, basic size is 50 mm diameter and negative unilateral tolerance value is minus 0.3 mm to 0 mm. For this unilateral method, like these methods are represented in engineering drawing. Then bilateral tolerance. Here the tolerance values are partially in negative side and partially in positive side. In this bilateral, there are two types, that is equal bilateral and unequal bilateral. This equal bilateral means that tolerance value is equally located in positive side and negative side, and unequal bilateral means the tolerance zone is unequally located in this positive side and negative side. For example, we will take the same circular shaft with some dimensions. This dimension is for our reference only. Here basic size is 50 mm diameter and equal tolerance value is plus or minus 0.5 mm. I mean the tolerance value is from minus 0.5 mm to plus 0.5 mm and unequal tolerance value is from minus 0.3 mm to plus 0.5 mm. For bilateral tolerance method, like these methods are represented in engineering drawing. Finally, limit method. In this method, these limit values are added with basic size. For example, you will see the first figure, there is 50 plus or minus 0.5 mm. So these limits are added with basic size. So the tolerance zone values are from 49.5 to 50.5 mm. So within this tolerance zone, the product should be manufactured. So we will see the another example. Here the values are 50 minus 0.3 to plus 0.5. So the tolerance values are 50 minus 0.3 is equal to 49.7 and 50 plus 0.5 is equal to 50.5. So within these values, the product should be manufactured. So like this, the tolerance values are represented in limit method in an engineering drawing. Now we are going to see limit. When we have studied about tolerance, so many times we used this term. Normally, limit is split into two ways. One is upper limit and another one is lower limit. Already we know what tolerance is. So, within this limit, tolerance zone are placed. For example, we can take one circular shaft and we just imagine its basic size is 50 mm and this is the baseline and this is the lower limit and this is the upper limit. In between this limit, tolerance zone is located. For example, we can take the value of plus or minus 0.05 mm limit values. So, lower limit is minus 0.05 mm and upper limit is plus 0.05 mm. So, the tolerance value is add the distance of minus 0.05 plus 0.05 is equal to 0.1 mm. So, this is the tolerance value. Within this limit, product should be manufactured. Finally, allowance. Normally, allowance is split into two ways. First one is positive allowance and second one is negative allowance. And allowance means it is a small gap between the two mating paths. For more clarity, we will take one shaft and hole in a rectangular plate combination. In this combination, the rectangular plate is sliding in this shaft. Like this, Every mating parts are work with one another. During two parts are mating, there is a small gap are providing in between the two parts for functioning that part, and that gap is called as allowance. Now we are going to see two types of allowance. First, positive allowance. We can see this figure. This is the hollow shaft and this is the circular shaft, and this shaft is sliding inside the hole of this hollow shaft. You can see here there is a small gap is provided for shaft will be sliding freely inside this hole, and here if the diameter of shaft is smaller than this diameter of hole, then it is called as positive allowance, and this gap is the positive allowance. Second, negative allowance. We can see this figure, and here too the shaft is located inside the hole of this hollow shaft. If the diameter of shaft is larger than this diameter of hole, then it is called as negative allowance, and this distance between this shaft and hole is the negative allowance. So finally, if shaft diameter is smaller than hole, then it is positive allowance, and if shaft diameter is larger than hole, then it is negative allowance. Here you see, in positive allowance the shaft is freely moved inside the hole, but in negative allowance we need to use some tools such as hammer to insert this shaft inside that hole. And here you see there is a small gap is provided in between this shaft and the hole, and this gap is called as positive allowance. And here there is a small distance in between this shaft and the hole, so this distance is called as negative allowance. So this is the basics in allowance. So I hope now you understand what is the differences in between dimensional tolerance and geometrical tolerance, and I hope now we understand these basic terms. So I will continuously upload the videos on mechanical concept.
Thank you for watching this video, and don't forget to like this video. So if you have any doubts, kindly comment it and turn on the bell icon, and don't forget to subscribe our channel.